Hi everyone, good evening and welcome to the Constellation crew, a group of Ball State students and myself, director of the Brown Planetarium here at Ball State University. Tonight we're going to be talking about the constellation Andromeda. And don't get that confused with the galaxy Andromeda, because we're going to be talking about that later. So there's two different objects out in space that we can explore, a constellation called Andromeda and then a galaxy called Andromeda. Well, we have Nicolette here to help us with that. Hi, Nicolette.
Hi.
And then we have Caleb. Hi, Caleb.
Hello.
And we have Ricky. Hi, Ricky.
Hi.
All right, so Nicolette, Caleb, and Ricky are going to be helping us out on screen, exploring the sky with our simulation of the sky here in Muncie, Indiana. But we also have one more member of our Constellation crew, Melanie, in the chat, who's going to help with any questions that you have or answer some of your questions, and then maybe you can help answer some of the questions that we ask during this presentation. Okay, so we're in our simulation here of our sky and our Earth. We're looking down on campus like we usually do with our Constellation crew, and we're looking at a part of campus with some cars. There's a small street here. It's maybe a little bit hard to see, but there's this round feature right here, and that is a statue. And if you're familiar with Ball State, you might know that we have Beneficence, our angel, not an angel, I guess, but we have a statue called Beneficence, and that's what we're looking down on here. And we're facing south. That S there does stand for south. All right, so we have S for south, we have SE for southeast, we have SW for southwest, and then of course we have more of the sky that's out of the field of view here. So we're facing south right now, but there's a lot more that we can explore, and we're going to shift our view around during the presentation to see different parts of the sky. But to really explore the sky, excuse me, in order to explore the sky, we're going to speed up time. So I'm going to speed up time in our simulation here, and we're going to have the sun set over on the right side of the screen here, over in the west, or appear to set because Earth is spinning. And let's face east to see objects appear to rise. So the sun rises or appears to rise in the east, but so does Mars, that red object here, and the stars, the points of light here that you can see that are not planets like planet Mars here, but stars similar to our sun. And let's put a label on that so we can remember what that object is, because it looks like a star in our sky here, but it's actually the red planet Mars. And it's kind of in an interesting location in its orbit, right, Caleb?
Yes, that's very correct. Mars right now is in what astronomers call the opposition, meaning that it's opposite the sun in the sky. Whereas the sun just set, the Mars is just rose, and so we basically be able to see the full face of Mars at night.
Yeah, we can see it like all night long, right?
Yep.
All right. So what does this look like from space? Okay, so this is our view on Earth after sunset tonight here in Muncie. So October 9th after sunset, we can see Mars in the east. But let's see what this looks like from space. All right, so if we're looking down at our solar system, we have the sun in the center of our solar system, or about the center. We have, some planets in between here. We have Mercury and Venus that aren't showing in this graphic, but we have Earth here, and then we have Mars out farther from the sun than we are. And this is showing what that looks like from space, what opposition looks like from space. So on Earth, as Caleb said, as the sun sets, Mars is rising. Mars is opposite the sky as Mars, or Mars is opposite the side of the sky as the sun, excuse me. But do the planets really line up exactly like this? Like, what does this maybe look like from the side? Let's check it out. All right, so this is a top view, but let's see a side view here. So the planets, as they orbit the sun, the orbits are a little tilted, right? And Earth can orbit the sun here, going around this direction. Mars orbits going around as well. And sometimes they are close together in their orbits. And the closest approach actually happened a few days ago, right, Caleb?
Yes, a couple of days ago on I believe it was Tuesday, Mars and Earth became as close as they could be during this opposition. But now opposition is not yet happened. Opposition will occur in a few days on the 13th.
Yeah, so closest approach is different than opposition. So it can get closer because of this tilt here. Just the shape of the orbits too, because they're not completely round out in space. They're kind of oval shaped. And so Mars actually made its closest approach back on Tuesday. Yeah, Caleb, that's right. And it was about 38.5 million miles from Earth. Still very far, but close. And if it's closer, it's going to appear a lot brighter in our sky, and therefore a little redder too, because it does appear like a reddish star in our night sky. Hence the name, it's the red planet, right? I hear that this is like the closest it's going to get to Earth until 2035. So it's going to get, close, and it's going to go into opposition before then. But the next closest approach, as close as this is this year, won't happen again until 2035. So how often does opposition happen?
Opposition for Mars and Earth, for Mars, happens once every 2 Earth years.
Yeah.
So, as seen by our dates over here, the last one happened on July 27th, 2018. And the next one will happen on December 8th of 2022.
Yeah. So not too rare, but rare enough. And again, it won't get as close as it is this year until 2035. So now is like a really good time to check it out, I think. And to find Mars in your sky tonight here in Muncie, just look east after sunset, and it'll be really hard to miss. All right, so we have Mars here. It looks red in your sky, red in our simulation here in the eastern part of the sky. Will it be as large as the moon, do you think?
No.
No. Have you seen that meme? Or
Yeah,
not? It's not
I've
even a
seen
meme.
that.
I mean, people have probably made memes out of it, but just the fake news out there. Yeah. It's not going to be as large as the moon in the sky, even though it's pretty close. It's just going to look like a really bright red star. But again, not a star, the red planet Mars. All right, so let's go and try to find that constellation that we're going to be talking about. So we're going to face southeast a little bit, and really remind ourselves of a few other objects in the sky, because those are going to help us find Andromeda. Andromeda is a little hard to find on its own. You have to have some, what are they called? Just like some guides to help you. And one of those is the summer triangle that you can still see tonight after sunset in October. And we've talked about the summer triangle before, but I want you to try to find the summer triangle if you're watching live on Facebook with us. So look for 3 bright stars in the shape of a triangle. And let's see if you found them. We'll outline that, what we call an asterism. There it is. So first you can try to find the summer triangle, really easy to spot. And then you'll look for a group of stars that we explored last week, the Great Square of Pegasus. So the Great Square of Pegasus are 4 stars in the shape of a square, and they're going to be kind of above Mars if you're facing east, or above the horizon if you're facing southeast. If you're looking at it kind of on its side, it might look more like a diamond or so on, but 4 stars here in the shape of a square. And not every star has a name from the International Astronomical Union, but some do. There's Markov and Shiat here. For does anyone remember what Pegasus actually is? So if you're watching and you remember what Pegasus is, put it in the chat. Because this is just a part of a constellation. This is another asterism, just another easily recognizable pattern of stars in the sky. And this is a part of the larger constellation Pegasus, which is an upside down flying horse, but only half of an upside down flying horse. And we'll see why in just a little bit. But Markov and Shiat here are the horse's chests. And in the backside here, there's Algae Neb and Alpheratz. Well, Alpheratz is actually the beginning of a constellation, and it's the constellation we're exploring this week. And before we show that, just a reminder that constellations are just a way to map out our sky. We have 88 official constellations from the International Astronomical Union, and they're just a way for astronomers and people now just to find things in the sky a little bit easier, to navigate it a little bit better. All right, so what's up with Alpheratz, Ricky?
Well, yeah, actually, that's kind of a good point because it wasn't until 1930 that we actually had the definitions for constellations that we use today. And prior to that, Alpheratz was considered to be both in Andromeda and Pegasus. So even though it makes up the body of Pegasus, it's part of the square that makes the body, it's actually the head of Andromeda. So that's kind of cool because it used to have the designation of Alpha Andromeda as the brightest star in Andromeda and Delta Pegasi as, like, I think the fourth brightest star in Pegasus. But now it's just Alpha Andromeda. It's pretty far away. It's 97 light years away. There's a couple neat things about it other than just being the first star in this constellation. The first one being that it's actually a binary star, but it's a spectroscopic binary. So
All
what
right,
that
so
means is,
go ahead.
got a problem? Oh, yeah, so what that means is that it's just you can't see two stars in a telescope, but you can tell by looking at the chemical makeups that there's two there. And then the other neat thing about it is that it's a navigational star used on sea charts. You can use it to find where you are on the Earth.
Cool. So,
What
like,
were you gonna
even
say?
though it looks like one star here in our sky, there's actually two stars there, right?
Yeah, there's actually two stars there.
Cool.
But you can't tell it with a regular telescope. You have to use the special ones that tell you what they're made out of.
That, like, kind of separate the light into its component colors and all of that.
Yeah.
Right.
Yeah.
Okay. Yeah.
You can see it in an observatory with those really high-tech ones. You have to use
Yeah. Yeah, as long as you have a spectroscope, you can look through it and it'll filter out all the lights. Like, have you ever seen the Newton thing where it takes the white light and splits it into a bunch of different colors?
Yeah.
A spectroscope will do that, and it will do that so you can see these bands show up, and that tells you exactly which elements are producing the light. So you can tell what the stars are made out of, and that lets us see how far they are in their stage of evolution, like what they're fusing, what's in their atmosphere, and in this case, you can see a difference in the way those patterns shift, and so you can tell that there's more than one star there.
Yeah. So, light is so important to astronomers, right? So when I am giving school groups presentations in the planetarium when we're not in quarantine, we always talk about rainbows because rainbows are pretty much they tell us a lot about the stars. We can study the rainbows, but scientists have to be really fancy. They don't call it a rainbow from a star; they call it a spectrum. And they get it from separating, the light coming from stars into their component colors. And so you can look at, something that's equivalent to that or related to that to study a little bit more in detail. And there's other ways to explore the sky besides just light. There's other ways to explore space. We're in the era of multi-messenger astronomy now, and we can study the sky with gravitational waves, which is really cool. Ripples in space-time, and then through other means as well. So really interesting to explore. We can explore the light, and it's not like taking a picture, right? Like you don't like see a picture of this. You get data that you can then analyze and infer from that data that there's more than one star there, right?
Yeah.
Cool. All right, so we have all these lines connected, right, for Andromeda. But if you kind of use your imagination, Andromeda is a person, a princess. We're going to be learning more about her at the end of the program. But let's talk more about what's kind of there that you need the help of a telescope to see, or maybe a pair of binoculars. So, you know, if we fade back down and just look at the stars here, and this is showing a sky that's kind of similar to what you would maybe see in Muncie with light pollution. You can see there's off of the square of Pegasus. So if you can find the Great Square of Pegasus, the top left star here, it's the beginning of Andromeda. That's Alpheratz. And it kind of stems out into this V shape of stars here. And if you can find that pattern, then you found the constellation Andromeda. But there's more there. Like I think right around in here, there's something interesting, right? That you can see with a pair of binoculars, Nicolette?
Yes, you can. And you can see it with a pair of binoculars. It's best seen in October through December. So it's the perfect time to whip out your binoculars or lower level telescopes, and it's called NGN 752.
NGC 752.
NGC, thank you. NGC 752 is an open cluster. So in past presentations, we've talked about globular clusters. This one's an open cluster, and it's very much different.
All right, let's see it. See a good picture. This was definitely a picture taken with the help of a telescope.
Yes. So there's a lot of stars here, as you can see, but it's not as many globular clusters have, as you can see in this photo here. There's a significant difference in the number of stars, which is one of the characteristics of an open cluster. They don't have as many stars, and they're also loosely gravitationally bound. So the globular cluster, there's a lot more gravity, which keeps them all more condensed and in a tighter space, which is why once you look towards more the center of this picture, it really gets hard to tell what star is what star. It starts to smush together into one light. But in an open cluster, you can pick out the stars. If you look at the photo, you can pick them out.
All right, so open star cluster over here, and then globular star cluster over here. We've been looking at a lot, like Nicolette said, we've been exploring so many globular clusters, and when we got to Andromeda and found out there was an open star cluster, we were like really happy because we got to talk about something new, right? Yeah, the open one. Not every star here in this picture is a part of the cluster, right? Like, because these are things that are gravitationally bound together. They're clusters of stars. It's not a binary star system where there's two stars typically in orbit gravitationally bound together. There's multiple, hundreds of them, right?
Yes.
But I don't think I think some of these are background stars, right?
Yes, some of them are background stars, and many scientists believe that open clusters are known to spread out over time. It's not quite clear if they spread out and then there's no more clusters, they just kind of move out on their own. It's not clear if that's what's going on, but they are known to separate over time because the gravity in open clusters are not as strong to keep them together like a globular cluster. So that's why they're very spread out, and it looks like other stars are a part of it, but it's not as many as you would think.
Yeah, I think the other stars look like they're a part of it just because it's a little bit closer to us than some of the globular star clusters, and so we're just seeing some other stars in the same field of view.
Exactly.
Because it's a little bit closer to the plane of our galaxy where we have lots and lots of stars.
Yes, yeah. And as you may have noticed in the other pictures, globular clusters kind of have some sort of shape, if you want to call it that. They're a little bit more round. They are all really tight together in a ball. Open clusters are known to have more random shapes. They're not quite round because they're all spread out. So they have different kinds of shapes, not necessarily names, but just different looks to them. They're not all spherical or close to spherical like a globular cluster is.
Yeah. Yeah, and they could get like kind of torn apart from close encounters to other stars out there, globular clusters. No, not maybe not globular clusters, but other clusters of stars and other nebulae, so clouds of gas and dust and so on, that could tug them a little bit. And if they're not, as gravitationally bound as the globular star clusters, are going to get torn apart a little bit easier, right?
Yes.
So I know that we always teach the audience about a certain open star cluster in the sky that's really easy to see with just your eyes. So do you all know what a popular open star cluster is? It's in the winter sky. It's in the constellation of Taurus, the bull. It's the emblem for Subaru cars. Starts with a P.
Oh, it's the Pleiades.
It's the Pleiades, yeah. So the Pleiades star cluster. That's an open star cluster. It looks like a little dipper in the sky.
That makes sense. I don't know why.
Little dipper.
I always just thought only 7 stars.
Yeah, there's like over 1,000, and they're all really blue, really hot stars. Yeah.
I literally thought that was its own little asterism. That's so cool.
Yeah, it could be. I mean, like, I'm sure it's like I don't know if it's an official asterism. I don't know if there's an official list of asterisms or if it's just kind of put together by amateur astronomers or so on. But yeah, I'm sure people call it the little dipper all over the place.
The mini dipper.
Yeah. Okay, so
I think it's also called this.
Go ahead.
Never mind.
We're gonna like also look at galaxies this show. So I'm looking at this picture and I was looking and I was like, that doesn't really look like a star. That looks more like a elongated smudge, and that's not what stars look like. And so when you see like an elongated smudge, you can kind of think that that might be a galaxy. Does anyone else see it?
I can kind of see what I can trick myself into thinking are a couple.
Yeah, there's a couple, like maybe like this one right here.
Yeah.
That might be a galaxy. Maybe this one. I'm not sure though. That kind of looks like a star.
I think it's the one over to the left and the up.
This one? That's the one that I saw first. That one I think is for sure a galaxy.
Wow.
So we're looking at stars within our own galaxy, and then be way beyond our galaxy, our other galaxies, and we can sometimes see them in our field of view. Maybe what about this one right up here? It's another one.
Oh, that's so small.
Yeah.
All right, so we were going to talk about galaxies. Let's go back to our constellation here. And can you all find the Great Square of Pegasus again? Right here. And then again, remember to find Andromeda. Go off of this star here, the top left star. And there's 2 strands. Kind of looks like a really long, curvy V. And in this area of the sky, this is the constellation of Andromeda here. In Andromeda is a galaxy called Andromeda, named after the constellation that it's found in. But we have
I was wondering which one was named first.
Yeah, it's the constellation first, and then the galaxy. Yeah. So we gotta make it darker to maybe see that, because there's some really cool things with it. But let's turn off the light pollution in Muncie here. All right, so when we turn off light pollution, we're turning off all of the street lights, houses, businesses, all of their lights and everything. And eventually, we should see more stars in the sky. There it goes. And a lot more than just stars. Like, there's this hazy band of light going across the sky that we can see now. And a lot of people know what that is. That's the Milky Way. But I like to remind people that when we look at this part of the sky, we are looking into the plane of our galaxy, the Milky Way galaxy, where there's lots and lots of stars, hundreds of billions of stars. But when we're looking over here and seeing stars, we're still looking at parts of our galaxy. The stars that we see over here are still a part of our galaxy. They're closer to us, so we can see them as points of light in the sky and make our constellations out of them, like Andromeda. All right, so Andromeda, remember, is over here. So do we see a smudge in this area of the sky?
Yeah, right about in the middle of where you're circling.
Right here.
Yeah.
Yeah.
All right, so from what we learned looking at that open star cluster, the smudges are maybe galaxies, right? So this is the Andromeda galaxy. Yeah. All right, so what's interesting about it?
Well, there's always the regular facts, like it's 2.5 million miles away. There's like a trillion stars in it. It's like 220 light years across. Um,
200 trillion.
Well, it's also,
2.5 million light years away, right?
Yeah.
Yeah.
Did I say something different?
I don't know.
I was probably talking too fast. Yeah, but 2.5 million away, 220 light years across in diameter. I might have mixed those two up. But it's also a barred spiral galaxy, just like the Milky Way. We think might be. We know it's a spiral. We think it might be barred.
And I
Another
think
thing, it's the.
Melanie's got a picture of it. She's going to put in the chat for us.
All right, that sounds cool. It's the furthest unaided eye object that we can see. There's actually a neat story about that, where in the 1920s there was the Great Debate, where a guy named Herbert Curtis debated Harlow Shapley, and they debated more things. But one of the things is that Curtis claimed that the Andromeda Nebula at that time was its own galaxy, that it had to have been so far away that it couldn't possibly be part of the Milky Way. And they had this argument, and 5 years later, Edwin Hubble settled that debate by figuring out that it absolutely had to be way too far away. He didn't quite get the number right. He was about half off, if I remember right. He only said it was like 1 million miles away, something like that, 1.5. I might be misremembering that though.
Miles or light years?
Did I say miles again?
Yeah.
Light years. I'm trying to think of miles because it's coming at us at 68 miles per second.
68 miles a second?
Yeah, it's because it's coming almost straight for us at that. I think that works out to like 250,000 miles an hour, just coming at us.
That's amazing.
Yeah.
Yeah.
So it is on a collision course, right? Or like
it's gonna hit us.
Collision course.
Yeah, or we're gonna hit it because I guess we're technically going towards each other because we're not stationary either.
All right. So what scientists have an idea of what that might look like. So I'm actually going to pause it so we can set this scene up. Go ahead, Ricky.
Oh yeah. So this will be. Ooh, I should have done my homework. I think it's Andromeda on the left and us on the right because Andromeda's bigger than we are.
Yeah, I'm pretty sure that they're depicting Andromeda here as a little bit larger than our Milky Way over here. So I would assume that as well. And we always like to have things coming in from the left that like are, alien, I guess, to us.
Yeah, good old conventions.
Yeah. There's other smudges here. Those are not other stars, but whole other galaxies in our universe, really. So yeah, I'm pretty sure that up close here we have Andromeda and then our Milky Way. But this is just a simulation.
Right? Yeah, this hasn't happened yet.
This hasn't happened yet. We don't have a picture of our galaxy even from the outside. Like this is not real life. But this is based on real physics, right?
Yeah, well, we kind of have an idea of what these would look like because we see a bunch of different galaxies in various stages of colliding and merging. So you can see this happening, and it kind of looks really violent, right? But galaxies are so big and the stars are so widely spaced apart that it's very unlikely that even a single star-on-star collision happened. It's very, very unlikely.
Yeah.
And
so someone put in the chat that this won't happen for about 4 billion years, and yeah, it won't happen for like 4.5 billion years or so.
Yeah,
so
something like that.
Down the way.
Yeah, the sun will be nova by then anyway.
The sun will turn into a red giant in about 5 billion years.
something like that.
And then it'll take another million years or so to turn into a planetary nebula and white dwarf star and everything. But like it's basically at the end of its life at that point.
Yeah, so we won't care about this happening. But even if we did, we would notice because it would be so bright, but it wouldn't really affect us unless we got very unlucky.
Yeah.
But like the worst thing that could happen is the whole solar system could get ejected out of the combined new like Milkdromeda.
Yeah. So what are they going to call it? Like, what is the name for this?
There's two that I've found.
What's the other one?
Milkdromeda and Milkdromeda, I think, are the two that I've found.
Oh my goodness.
I had it down too, but so it's Milky Way and Andromeda, so they kind of combined the it's
I like
Milkomeda
Milkdromeda
or Milkdromeda. Milkomeda.
Yeah.
What one
I
do you
like
like
Milkdromeda
better?
more.
Milkdromeda.
Yeah.
I think that's more dramatic.
Yeah.
It
That's
sounds
probably
like
why I like it
Andromeda.
more. It does kind of, yeah.
The world of science has funny names for everything.
Especially astronomy. Like
Yeah.
it's a square in the sky. Just call it the Great Square. It's a triangle that's up all night in the summer. It's just a summer triangle.
When exactly, I hope you know, does it get reclassified as a new galaxy? Is it when the black holes merge, or when they get close
That's a
enough to
good
start making
question.
gravitational waves?
I don't know if people know, but that was one of the things I was going to ask. Like each one of these galaxies, they have a central black, like supermassive black hole. We have in our Milky Way galaxy Sagittarius A star, which is a supermassive black hole in the center region of our galaxy. And then Andromeda has its own black hole in the center. It's called P2. And so these, they're going to take a long time to merge. They think that after millions of years, the two black holes in the centers of each of these galaxies, P2 and Sagittarius A star, are going to merge due to something called dynamical friction, sometimes called gravitational drag. So just basically the loss of momentum and kinetic energy through gravitational interactions.
Yeah, well, that's what we use to slingshot satellites off of planets.
So,
well, it's the same principle.
Same principle. I mean, yeah, because we can speed up spacecraft going around other planets. We can actually use the same similar methods to slow it down too. Yeah.
Here's a question. So you mentioned that it's rare that there'll be a star-on-star collision, but say there was one and we were close enough to it, what would happen?
Well, if we were close enough to it, we would notice. Well, I don't know how close you mean, because it could just be this really cool explosion, or it could just be something that we didn't know happened because we were too close.
I've heard that if you're close enough within 2 parsecs, it's very bad.
Well, I guess that would depend on how fast the stars were going and how big they were, the exact number. But two parsecs sounds.
That still sounds pretty far to me.
Yeah, parsecs are pretty far.
And just a reminder, what's a parsec? 3.26 light years?
So yeah, it's about that. I always just shorthand it to about 3.
I got it right. Yeah, 3.26 light years. I remember it because 3 times 2 is 6.
And it rhymes with parsec.
So it's just 3. Yeah, 1 parsec is 3.
That's a good mnemonic. I like that.
Years.
I'll try and steal that.
Yeah, whatever I can do to help with that. All right, so yeah, I don't know when they would decide that this would be. I think like after it gets settled down, because we see examples of this. Like we have the Mice and the Tadpole nebulae, or excuse me, galaxies out there.
Yeah.
That you can definitely see they're in the middle of merger, and they're called more of like irregular galaxies. So this right here would be like more of an irregular shape, right? So it's not.
Yeah, we don't know like exactly what type it would become.
Yeah, we don't even see here really the final thing. I think they actually do think that it's going to become an elliptical one.
Yeah, I think it's either elliptical or lenticular, or the two, most likely.
Yeah, so maybe that's why it cuts out here. They don't know, so they're just going to leave it. I wonder what the actual simulation though showed.
Yeah, I wonder how long they ran it for.
Yeah. All right, so that galaxy that's on a collision course with ours is in the constellation Andromeda, off of the Great Square of Pegasus, and it's right here. And No, don't expect to see that here in Muncie. You have to go in a really dark location and really look hard for it to be able to spot it, I think, in the sky. But it is the farthest object in our night sky that you can see with the unaided eye. It's a galaxy outside of our own. Every single thing in this picture, though, or in this simulation here, everything in the simulation is a part of our own Milky Way galaxy, except for this smudge, the Andromeda.
Yeah. That's pretty cool.
Yeah. All right, so we're going to wrap it up with some stories about Andromeda and the mythology. There's a lot of great stories about the constellations in our sky. And what do we got about Andromeda?
Well, as you can see here, you're not going to see this beautiful lady in the sky when you look up. So this is just kind of what people depict from the stories. But this is Andromeda. She was a person in mythology, but she was this lovely lady here, you can see. She had a very unfortunate story. Her father,
There's
Cepheus,
a lot of unfortunate stories about the
yes,
constellations.
especially in Greek mythology. But she had a king for a father and a queen for a mother. And the queen, Cassiopeia, was very, how should I say, full of herself, and claimed that she was more beautiful than a lot of things. Many Greek mythology stories say that she claimed to be more beautiful than the goddess Athena, but in this case, she claimed to be more beautiful than the sea nymphs. And the sea nymphs got very offended and were very upset and went crying to Poseidon, another one of the Greek gods. And Poseidon decided to send a monster to the kingdom of Andromeda's mother and father as punishment for claiming that she was more beautiful than any of the Greek gods' creatures as such. And her father wanted all the attacks to stop and the sea monster to go away. So he went to an oracle, and the oracle said, the only way to get this to stop is to sacrifice your daughter to Poseidon. So poor Andromeda was then chained to a rock, which is why you see chains on her wrists. She was chained to a rock and was left to the sea monster as a sacrifice. However, she does have a happy ending. Perseus, the Greek hero, did come in at her rescue and rescue her from the monster. They ended up getting married and having 6 children. But this is also why she is very close to the constellation Cassiopeia and Perseus, because Athena felt that she should be put among the stars next to her loving husband and her mother. Although I'm not exactly sure why her mother is up in the sky if she did all those awful things. But I heard from Dana that it was more of a punishment.
Yeah, like Cassiopeia is definitely put up in the sky as a punishment. And we're gonna go all into that when we get to Cassiopeia. Not next week, but the week after that. We're gonna talk about Cassiopeia. And if you're interested, Cassiopeia is right here in the sky. Looks like a W here.
So she may have gotten involved in something she didn't want to. However, she did have a happy ending. Thank you, Perseus, the Greek hero, for saving an innocent.
Nice. All right, what's next week, crew? Do you remember?
I believe, what is it? Draco?
Yeah, it's Draco. Draco the dragon. And if you're a Harry Potter fan, yes, same kind of Draco. Similar. At least that's what the characters are named after. Yeah.
Yeah.
For the Dragonheart fans. Thank you.
Oh, Dragonheart. I love that movie.
Dragonheart?
Yeah. So
Yeah, it's been so long since I've
dragon
seen that.
becomes the last star in Draco at the end of that movie.
Oh, is that the one with the white dragon?
Well, that's one of the best scores ever. You know.
It is great music. Yeah.
All right, so Melanie, a part of our, who is also a part of the Constellation crew, who's been helping out in the chat, put a link to skymaps.com. They have a wonderful free sky map that you can download quickly. It's just a PDF file, and get it printed or view it on your phone or any other device. And use it to find things in the sky. There's also more of a high-tech option that she refers to called Skyview Lite that you can download as an app for your phone as well if you are able. All right, final thoughts, crew.
Well, this is a very interesting constellation with a lot of stuff in it. So especially considering the Andromeda galaxy and its own feature of their own galaxy, it's pretty interesting.
Yeah, a lot of people have the Andromeda galaxy kind of on their bucket list to see in the sky, to check it out and try to find it if they're in a dark sky location. But the thing is Andromeda is not always up in the sky. It's a constellation that sometimes is not apparent in the sky, is not visible in the sky. So you have to, if you're going to travel and see a really dark location, you want to see that galaxy, Andromeda, you have to do it at the right time of the year. And it's going to be up higher in the sky earlier in the evening as the year goes on here. All right. We'll wrap it up and we'll see y'all next week. We're going to be, again, exploring the constellation Draco, the dragon. And we hope to see you then. Until then, have a great rest of your evening and a wonderful weekend, everyone. Take care.
Bye, guys.
Bye.
Bye.